Ladies and gentlemen, it's a pleasure for me to be here today, and I am glad that I can connect to the great topics we have seen today about the digital twinning, about the artificial intelligence. And I would like to really show to you what we as a CEIT, part of the Asseco group, are doing in the field of the Industry 4.0, and what kind of case studies and projects we have been introducing in the recent past months and years. So let's start quickly with my introduction. I have been studied in Košice, management and automation. After 10 years spending in Germany working for the major domestic appliances producer, Whirlpool Corporation, I have switched to ABB for 4 years, working in the engineering team and focusing on the power electronics, which is now used in the electric vehicles and the hybrid vehicles. And after several years in that corporate, I've switched to the local company in Slovakia, which is called CEIT, and I started in the executive board of that company. Let me give you also a little bit introduction about the company CEIT and what are the key competencies we are delivering. So main idea of the CEIT is to deliver the complete solution for our clients. We are working long years. It's a 20 years anniversary this year with the OEMs in the Slovakia. You know that Slovakia is one of the countries where the production of cars per citizen is number one on the world. And we try to deliver to our clients the complete cycle of the solution. This means starting from the planning, looking into the product engineering, then focusing on the planning of the whole process and how the future production sites can look like, and then going to the smart factory solutions where there is a digitalization, a number one discussion topic at the moment, with ability to also deliver the final technical solution at the end. So we have been working for several OEMs in the region of Central East Europe. We are coming from Slovakia, founded in 1998, and so far we have been able to deliver more than 50 patents, utility models, supplementary protection certificates, which part are for our solution, for our products, and the rest is for the customers we have been working for. Since October last year, we are a member of the Asseco group, and I think that this kind of connection can really bring for the future clients great opportunity to provide complex solution which goes from the IT system up to the level, to the shop floor level or manufacturing level. So the core idea of this presentation from my side, which I would like to bring it to you, is to really share with you our view, our vision, how could the roadmap of digitalization looks like for SME, but also for the OEM, for the big factories. I will show you video sequences from some of the case studies we have been introducing and implementing on the factory levels. And before we really go through step-by-step process, I would like to give you a little bit conceptual understanding of what I'm going to talk in the later stage. So imagine that you are in the phase you want to upgrade your factory or you want to innovate your factory processes. So this is something where the digital factory is starting for. So you try to model your factory in the computer, you try to provide a 3D representation of your factory. Why is important that? The question is here because you want to simulate, you want to improve as much as possible in the virtual world. So you want to prepare your solution, which you will implement later on in the real factory, as best as possible layout. Once the real factory is done, and all the sensors, all the data are provided, so you start to collect your dynamic data. So how the processes are acting, and all that is create a big data collection which are later on used, and we call it in the CEIT as a virtual factory for the analysis, analytics, and start of the continuous improvement cycle. That putting together the digital factory and the virtual factory makes basically digital twinning. That is about the manufacturing processes. We have heard today morning several topics why is important the digital twinning and how these processes are important for the evolvement, advance of the factory processes. So that's what can be called several names, factory twin, digital twin, and so on. Helps us to do prediction of the processes, helps to bring the predictive maintenance stuff, artificial intelligence algorithms, which are at the end taking role of self-optimization or self-organization of the factory. With the purpose to provide to SMEs or small companies also ability to get into the digital world, and not only the corporate who are really strong in terms of the investment side to be applicable on that. We have developed kind of the roadmap of 6-phase roadmap, which gives some steps which can be done one by one. It doesn't need to be done everything at once with the massive investment. So the owner or the CEOs of the company can really decide which year, what part of the implementation they will take care. So now let me guide you and walk you through some video sequences which has been basically collected from the realization we have been doing in our clients. Again, a little bit connection between the conceptual part of the digital factory and the real factory and the virtual factory, so we will quickly go through it. The first phase calls digitization and the planning. No matter whether the brownfield or the greenfield factory projects, you always need to start to represent your facility from a 3D data. So for that reason, in case you look for the upgrade of your factory and you doesn't own 3D digital data, you start to create 3D scanning your 3D model of your facility, of your production sites. So it's really nice. You can go in a high detail view of your facility with the layout, with the machinery, with everything you have inside, which is later on used for the next stages of the optimization and other processes, digital processes. Also, one important point, why these steps is needed at the beginning, because here you can really evaluate many space analysis, and this helps you to prevent you for the huge investments once you will be farther in the process of the establishment of your building on the greenfield, and you will miss some things you couldn't collect at the earlier stage. We all know that the cheapest prevent the investments cost at the end is better to do in the beginning. The second phase follows, and here the dynamic simulations are used to optimize the layouts, to make sure that the production process is decided and divided in the right work for flows, and that there are basically used new technologies, augmented reality to validate and quantify all the needed KPIs which are important for the new factory. So this you can see some 2D and 3D simulations we have been doing for the logistics process setup, where you can go for high detail in terms of the production flow, and you can really do detailed analysis on how the process looks like. That's a very important point, because once you are done with your simulation, you basically start the trigger of your investments in the new factory. Okay? And there are as much details we collect in this way, as better it is for the future project plan and the timing of the factory. So the third phase, imagine, is going parallel when the implementation or the factory is currently in build. And here you can use already established 3D model of your facility for the training of the people. So for example, assembly of the car or any operation on the production line can be trained. Here we see currently the logistics operations. So there are many areas we have been already doing the virtual training systems for the assembly, for the quality purpose, for the logistics purpose, and one of the most important and mostly asked from our clients is the maintenance. So this is the robotic line where the future maintenance or service guy can learn how to operate the robot in a virtual reality. That saved cost for the OEMs significantly, because one robot is about 30 to 50,000 euro. They don't need to have a special training center, and they really standardize the level of the group of the service guys with this virtual training. So it's really very tricky tool to go on. Let me show you also some implementation pictures, or let me say some of our realizations. This is where the implementation phase is about, where we are moving from 3D into the reality. So implementing everything, fixing the equipment, commissioning in that according to the specification and all kind of solutions. So here, the automated guided vehicles, our main product, what the CEIT is delivering to the clients. This is an autonomous system which is controlled and is basically providing full intralogistic delivery within the automotive market. That's the implementation of some of the robotics lines which are fully equipped with the sensors and the control stations, and they can be integrated into the whole digital twinning concept of the manufacturing. So some manipulations of the components, control, quality, access, and so on. The next phase, once all the equipment is installed, is about to fine-tune the control systems. So we use for our intralogistics products kind of control system, central control system, which is managing the fleet of the AGVs. So in one hall, you need to see that there is a 60, 70 of the AGVs. Each AGV is driving 2, 3 conveyors, it depends. And our control system is able to manage not only the automatic equipment, but is also able to drive the manual forklifts and the logistics in the system. So that's something where the control system has defined paths and layouts of the logistics within the hall, within the manufacturing hall, and is also able to recalculate the paths in case there is any obstacle in the way. So that's something where in the morning each AGV doesn't know which path will go in the factory. This really depends on the material planning and everything what we are getting as an input to our system. The last phase is something what we call digital twinning. So that's where we are trying to online monitor manual logistics, automatic logistics, material, and equipment. So you are getting online information about what is the overall equipment efficiency for the equipment. You're getting an information where are the stuck places where the logistics is basically delayed. You're getting information what is, or let me say in which position the critical material is found. And what is more important, due to the fact that everything is built on one platform, you can put your training center for the forklift drivers inside of virtual reality. So they are really driving and training the forklift inside a virtual model, which is online connected with the real facility. So that's kind of the process how you can get into the digital twinning, or where you can really establish step by step and you can connect new functionalities on that. And here I will really quickly summarize what we have seen. So first, digitization and the planning part is about the modeling, visualization, 3D factories, and Industry 4.0 audit, which is telling us in which stage the company is currently. In the second phase, we have the 3D simulations and, let me say, evaluation, quantification of the final solution, let me call it like that. On the third phase, virtual training, so your preparation of the people for the future factory, implementation of automation, 3D printing and other process innovation parts. Fifth phase is about putting the control system, and the sixth phase is about digital twinning, where self-optimization and self-organization is taking place. Ladies and gentlemen, thank you for your attention.